The next two lessons are going to review some factoring. We're going to break into 2 days, give us a chance to practice, remind ourselves of the different types of factoring, how to use them. This is one of the key concepts moving forward to grade 11. You have to be able to factor. We're going to use it in all different kinds of places, in new situations, plus all the old quadratic situations. It's a huge thing. So if you have trouble factoring, you got to come in, you got to come see me, we got to work on some stuff. Okay, so yesterday we were doing expanding, right? We were getting rid of the brackets. Today we want to put them back in. First idea, can you find a common factor? Your common factor is your greatest term that all of your expression is divisible by. Okay, so I look at the first thing, I say to myself, what can I divide 12x and 4y by? And the largest number that can go into both those would be 4. Now, I prefer we take out the negative 4. I kind of always want to leave my first term inside the bracket as a positive. So when I divide negative 12 by negative 4, I get 3x. When I divide negative 4 by negative 4, I get minus 1y. This is common factoring. I can check it by thinking to myself, well, if I expand it back and multiply back out, do I get back to where I started from? Sure I do. The only challenge with the check is, if you don't take out the greatest common factor, it'll still work, but it won't be the right answer. So look at your brackets and see if they still have anything in common. Does anything go into 3 and 1? Are there any letters that are the same? No. I know I'm done then. Let's try the next one. What goes into 15 and 10? And both is by 5. I notice they both have the letter X in them, and they both have the letter Y in them. So that's also a common factor. So now I'm going to do 15 divided by 5xy. 15 divided by 5 is 3, and x divided by an x, there's no x's left. A y divided by a y, there's no y's left. Okay, 10 divided by 5 makes 2. X divided by x, none left. If I had 2 y's and then divide one of them out, though, I'm left with 1. Okay? And then the last one. What goes into 28a squared and 4ab? Both is by 4a. We're left with 7a minus b. And this should all be reminders. These aren't new things. We've done this for 2 years, actually, 9 and 10. A few more really quick ones. So 45, 50, and 60, common denominator. What can I divide them all by? Well, I can divide them all by 5, but I'm looking for the greatest common factor. So these are all divisible by 15. A little hint, always try the smallest of the 3 numbers. What else do they have in common? They all have an A and a B. So 45 divided by 15 is 3. There was 2 A's, but we took one out. No B's left. Minus 15 divided by 15 is 1. We took out the A, but it should be 1 B left. And 60 by 15 is 4. There's your answer. And the last one of these basic ones, 64 and 32. I tried the small number. Are they both divisible by 32? Yes, they are. They both have x's. How many x's? Well, the first part has 6, and the second part has 4, which means they both have at least 4 in them. And the y's, they both have at least 2. And the z's, they both have at least 1. Again, a little hint, look for the smaller exponent. So I compare y2 and y4. What's smaller? Oh, 2 is smaller. That's why I picked 2. Z1 and Z4. Well, 1 is smaller. That's why it was Z1. Let's divide. 64 by 32 makes 2. There are 6 x's. We took out 4. We're left with 2. There are no y's left. There's no z's left. We took them out. Minus 32 by 32 is 1. We took out all 4 x's. We took out 2 y's. We're left with 2. We took out 1 z's. We're left with 3. Again, check your brackets. Make sure there's nothing common left inside the brackets. That's how you know you're done. I see no common letters in the brackets, and 2 and 1 aren't divisible by the same number. Okay, let's try the next set of kind of questions. These ones can cause some confusion. In the next set of questions, we call this grouping, I have a group of things that are common. All of this bracket is common. It shows up on the left-hand side, and it shows up on the right-hand side. So if I factor out that group, all of x minus 2, I'll be left with a 3x and a minus 2. That can be a little confusing. Process that maybe. Try the next one. What group do we have in common? I see a 2x minus 5y on the left and the right. If I take it out, I'm left with a 2x and a minus 3y. Okay? There's still common factoring, but we're common factoring by grouping things. Okay. Why do I want that grouping idea? Well, what if I have more than 3 terms? What if I have 4 terms? But those 4 terms don't have something in common to all 4 terms. Do I give up? No. I look for a group of things that I can common factor. If I were to split this equation in half, I hope you would agree they both have a common factor of of x. If I take that out, I get 2a minus 3b. The next group has a common factor of y. And again, I see a 2a and a 3b, but my signs are kind of backwards. So if I take out the negative sign, I'm left with 2a, and a positive 3b divided by negative 1 makes minus. So by grouping things, splitting my equation in half, if you will, I was able to find a common group, and then I can re-common factor, do it again, and have an expression that has been factored. Okay, let's try the same thing in the next one. Hopefully you notice in the next one that there's a problem right off the bat. There's nothing in common in the first half. So think about algebra. We're allowed to move things around. Let's rearrange this, and it doesn't really make a difference which order you put it in, into a different order. As long as there's something in common that's going to produce a group down the road. By putting in this order, we can now see that we have a common factor of x at the beginning, and x minus y is left over. And I have an x and a y in the next part, but they have the wrong signs. So if I take out the negative sign, I'll be left with x minus y. And now I have a group. And we're done. Now that's one choice of order. You could have put them in a different order. It wouldn't have made a difference. It just means your brackets at the end will be in different order. The big objective there is you got to find something that you can take out to make the groups the same. Okay, second idea for today, simple trinomials. Simple trinomials are 3-term expressions where the number, the term, in front of your squared term is always a 1. So if you look at these 3 examples, there's a 1, a 1, a 1. If there isn't a 1, try common factoring first to make it have a 1. So for example, if I saw 2x squared plus 4x plus 6, I could turn that into x squared, 2x, and 3, and then this would be a simple trinomial because there's a 1 in front. Okay, when we're doing these kind of expressions, we're going to use things that multiply to the last number and add to the middle number. Okay, these things are called our factors. So for example, I want to multiply to 12. I want to add to 7. And what numbers do that? Well, the numbers 3 and 4. So my expression is x plus 3 and x plus 4. I need the x times x to make x squared, and 3 and 4 both have to be positive to come out to 7 and 12. Try the next one. It multiplies to 9 and adds to 10. The numbers that do that are 1 and 9. Now the order you put them in does not matter. You could put down x plus 1, x plus 9, or x plus 9, x plus 1. It doesn't make a difference. The signs are important, but the order does not matter. Yeah, try the next one. I want to multiply. I want to add. What does that? Well, to multiply 24, I can use 6 and 4. To make that come out to negative 2, the 6 has to be negative, and the 4 has to be positive. There's my factoring done. Okay, you guys are going to try some. So pause the video. You guys try, see if you can remember how to factor a little bit. Okay, sometimes these letter ones cause some confusion. I like to take care of the letters first. In order to get an x squared, I need to have an x and an x, right? That's how that comes about. To get a y squared, I need to have a y and a y. Then I don't have to worry about the letters anymore. What adds to 8 and multiplies to 15? Well, 3 and 5. And I know there's somebody out there who's going to say, well, how do you get this then? So think about FOIL. If we were to FOIL, x times x is x squared, x times 5y is 5xy. These two together makes 3xy, and then we get 15y squared. And if I collect, the middle takes care of itself. So don't let the letters confuse you. Take care of them first. Think about what do I need to put in the brackets to produce that when FOIL is done. With that idea in mind, let's try this one. How would I get an x squared y squared at the beginning? I would need to have an xy and an xy. So when I were to FOIL them, xy makes x squared y squared. I don't need to worry about the middle letters. They'll take care of themselves. I just need to figure out what multiplies to 18 and adds -7. I'll get -9 and 2. Done. Factored. Okay, letter F. There's a 2 out front. Hey, that doesn't look like a simple trinomial. We got to fix it. First thing I got to do is common factor. If I take a 2 out, and don't make it magically disappear, okay, that's kind of a common mistake. I need that 2 to hang out up front so I know what the value is when I want to expand it again, if I want to see if these things are equivalent. Right. Now I've got a simple trinomial inside the brackets. I can add and multiply x minus 4, x plus 2. But I need that 2 there so I can go back to where I started from to make an equivalent expression. If the 2 is gone, they're not equivalent anymore. You can't have an equal sign. Okay, let's try that in the next one. I notice, I don't even have, not even do I have a number out front. I notice they all have the same letter in common. So let's common factor out both. I can all divide by 3. They all have an x in them. We're left with x squared minus 3x, and 84 divided by 3 is 28. Okay, add and multiply. Don't lose the 3x. What multiplies to 28 and adds to 3? I need a -7 and a +4. Let's try h. I see a 2 out front. In fact, it's a -2. I like to take the negative sign out, so my squared term is positive. When I divide the next ones out, be careful with your signs. Divide them all by -2. Okay, let's add to 3 and multiply to 10. I need a +5 and a -2. And then the last one over here at the end, I see an x4. So I think to myself, common factor. Oh, but they don't all have x's in them. So I need to deal with the letters. How would I make an x4? Well, to get x4, I need something here and something here. It has to be the same thing. How about x squared and x squared? Because when I multiply them, I'll get x4. And they'll also take care of the middle term. What multiplies to 18 and adds to 7? Plus 9, -2. Okay, so letters first, common denominators, and then we're using our man idea, multiplying and adding. Okay, that's it. Our homework today is a handout. Okay, the answers are on the website, answers at the back of the classroom. You can check things out. You gotta be really good at factoring to be able to do it really quickly, because it's kind of one of our big ideas for the rest of the course we're just going to use to do most of the math.